Right, the purpose of this video is to look at AP Practice Problem 3, see the answers, and see how the points are doled out and what you needed to get all the points. All right, so this problem has a probability distribution table. The example, the context of it is that there's a university that has a STEM program, and they want to get an intern. They're for women, so internships are being given to women. And in order for a woman to meet the requirement for this internship, she must be 20 years or older. So we look at the university, we're looking at the people and the distribution of their ages, right? So most people at a university, not everybody, but most of them in their late teens, early 20s, maybe to mid 20s, right? You get a few old people. You might get the rare, person who graduated super early or had something go on in their life where they're, like 16, they're able to go to college. But most people are, and you can see here, 18 to 22. And they give you the probability that you get someone like that. So there's not many people who are 17. There's a reasonable number of people who are 18, 19. Looks like a good chunk of people are 20, 21, 22, and then it drops off again when they're older. All right. So now that we have the probability distribution, so this is basically how all of the women at the college break up by age, and knows that they're not equally weighted, right? Just because there's 1, 2, 3, 4, 5, 6, 7 categories doesn't mean they're evenly spread, right? There's more people in this section than in these outer sections. So now that we kind of get, it's the probability of getting someone in each age, or basically it's the proportion of the population that has this age. Let's see what they ask for. So part A says, suppose one woman selected at random from the women in the STEM majors at the university. What's the probability that the woman selected will not meet the age requirement? So basically they just want to know what's the probability you get somebody who's under 20, because in order to meet the requirement, they got to be 20 or older. So who's not 20 or older is everyone who's under 20. There are 3 categories here that are under 20. Someone who's 19, someone who's 18, someone who's 17. Now, these are mutually exclusive categories. It's not like you can be both 19 and 17 at the same time. So the good news is you can just add these together and get the probability. So add this to this to this, and I believe that totals 0.223. So you could say you have a 22.3% chance, or just say 0.223 is the probability that you get a woman who will not qualify. All right. So then they move on. They talk about a sample of 100 women in the STEM major are going to participate in a focus group. So the key thing here is that they have moved to a sample, right? So they're going to grab 100 women out of this population, and we'll see what they want. So they go, suppose a simple random sampling process is used to select a sample of 100 women. What's the probability that at least 30% of the women in the sample will not meet the age requirement for the internship? So what we know from the problem before is that the most likely scenario is you'd pick and you'd get about 22.3%. Now, 22.3% is the most likely outcome. You can get outcomes that are different, but the farther you get from 22.3%, the less likely it is to happen. So 30% is kind of, it's somewhat far from the 22.3%, but it's possible, and we want to see what's the chance that, it's probably at least. So this would be 30%, or more. So this isn't going to be very likely because, like I said, it's kind of far away. So to get up to 30, but we need some kind of measurement of this. Like, how do we know how far away we are and what it is? So there's actually 2 different ways to look at this problem, because basically we know the population proportion. We know that in general, 0.223 of the population meets this criteria. If we pick 100 people, we want 0.3 of them to meet that requirement. So I'll show you my work for the 2 different ways of looking at it. Basically, you could use a binomial distribution, or you could use a sample proportion to solve this. So when I did it, I came up with the sample proportion method, and I didn't really think of the other one. They accepted both. The binomial is actually the better of the 2, but it doesn't matter which one you use. So let me show you just the quick work. If you use the binomial distribution, remember, binomial distribution has probability of success, probability of failure, and the number of trials that you're doing. So basically, you can think of each person, you have 100 people, and this is their chance of getting someone who meets the requirement and someone who doesn't, and you could calculate this probability. So if you use binomial CDF, remember it goes from the left, you could figure out, well, what is the probability that this is going to happen? Now, how am I outlining it? Well, I want 30 to be my cutoff, right? I want 30 or more because this is my probability of success, but in the end, I want 30% or more in order to reach this. So in the binomial distribution, 30% would be 30 out of 100. So I would want 30 successes. I can't go on the right side of the curve using the calculator, using a standard calculator. So that's why I have the number 29 here. Instead of going 30 and higher, I'm going to go from 0 to 29. It's the opposite of what I want, but then I can subtract it from 1. So basically, the binomial distribution, I want to have 100 people picked, so sample size is 100. This is the probability of success, and I basically need to know up to 29 successes. So if you did the PDF, it would give you the chance of 29 successes. I want the chance of 0, 1, 2, 3, all the way up to 29 successes, right? So that would cover what I actually don't want, right? I want 30 or more, but this will do up to 29. So what's the probability that in this sample of 100 women, I get 0 to 29 of them that meet the criteria? Well, it's a pretty good chance because I said, each one of them has a 22% chance. So being between 0 and 29 is likely to happen. It's about 0.9547. So now remember, this area was from 1 to 29. It covered, actually, probably covered 0 to 29. I think I wrote 1, whatever. This covered the left side of the binomial distribution. I want 30 or more. So 30 or more is the leftover of this. So what's left over is 1 minus that amount, which is 0.0453. This is the binomial solution for it. Basically thinking of 100 people, the rate of success. The rate of failure doesn't go in the calculator, but that's the rate of failure. The rate of success, and then having basically a low number all the way up to 29 of those successes. And subtracting that from 1 will give me 30 or more of those successes. Remember, if I get 30 women or more, I'm at 30% since I'm out of 100. So 30 or more, the probability of 30 or more doing that would be the probability of getting 30% or more, and that's the leftover from that binomial distribution. Then the way that I actually did it, which I think is a little easier, is the sample proportion method. When we did all that stuff with sample proportions and the tests and the intervals and all that stuff, basically, if you're drawing from a population that has this proportion in it, right, this proportion of success, the chance that a woman is going to, make it into this program is 0.223. So if you're going to pull out a lot of samples of this, it's going to roughly look normal. Like, I didn't show you the binomial distribution, but if you saw the binomial distribution for that, it would be roughly normal. So instead of using the roughly normal one, I'm going to use the actual normal curve to approximate it. Well, if this is the proportion of the population, this is my p-value. If I pull out samples of size 100, most of them are going to have this as their value, right? So if I pulled out 100 women, I'd expect 22.3 of them on average to meet my sample, in that sample to meet the criteria. So remember, the farther I go from that value, the less likely I am to get it. So basically, I need the mean and standard deviation of this to know, well, 30 isn't this number, 30 is kind of far away. What's the chance it's 30 or more? So I need the mean, so the population proportion is the mean of the sample distribution. So if I pull out 100 people, what proportion are going to make it, like we did in the box, what proportion are going to be correct? And then I need the spread of this curve. The spread of this curve is the proportions sampling distribution standard deviation, which is square root of p times q over n. It's used in a lot of those inference formulas. So the standard deviation is p times q over n, which is 0.0416. So now I can use a z-score to go, well, this is what is most likely to happen. What's the chance I get 30% or more in a sample of 100? Well, get the z-score for this. It's this minus this over the standard deviation. That value is 1.85 standard deviations out. That means it's not that likely to happen, right? So What's the chance it's 30 or over? There's the p-value, or if you put this in the calculator, like I said, you can do this with a normal CDF and just use this value, normal CDF, this value for the z-score, and then 9999 for the other z-score. It'll give you that area that's in there. Comes out as 0.032. Now, they're a little bit off because this one's a little more exact, and this one's just an approximation using a normal curve, but they're both acceptable answers. They're both, 4, 3, whatever percent. So I get 3.2% this way. So this was the way I did it, that I thought to do it, but you could also do it with the binomial distribution, because the binomial is actually a little more exact, but this thing is a little easier, a little more powerful. All right, so those are the two solutions to that. That one was pretty mathy compared to some of these other questions. So let's look at the last question then. This one's a little easier because they basically go, suppose a stratified random sampling design is used to sample 30 women who do not meet the age requirement and 30 who do not meet the age requirement, and a sample of 70 who do meet the age requirement. So we saw that on average 22.3% should meet the age requirement. They're forcing it to be 30-70, or basically 30 out of 100, or 30%, like in the problem above. So it says, based on the probability distribution, is a woman who does not meet the age requirement more or less likely or equally likely to be selected with a stratified random sample. So remember, stratifying forces the proportions, and what we saw from this right here is here's the sampling distribution. Most of the time, you should be getting this kind of sample. So, and we saw that from up here, the population was 0.223. So this is what we expect. If we pulled 100 people, we'd expect to get 22.3 of them roughly to meet it. So when we force it to be 30, we're overrepresenting those women, right? So the ones that do not meet the age requirement are being overrepresented in this sample because they're not supposed to come up that often. They're supposed to come up what we found before, the 0.223. This makes them come up at 0.3. All right, so the stratified is overrepresenting them, and that's what they're going for. All right, so now let's look at the point totals for this problem. Make sure we got the right sheet here. All right, so for this problem, part A, part A was you needed to get the correct answer, so that was that decimal answer or percent, and then the supporting work. So what I mean by supporting work is, here's my work. They needed to see something about you talking about those three groups and adding them together. If you just put this number down, it doesn't justify how you got it. So unfortunately, this is like when I'm talking about them being nitpicky, is they should just accept this as an answer, but they really want to see how you got it. So show the work. The correct answer in the supporting work, E gives you both. If you have, and this is the killer, if you have the answer with no work, you get a P. And then they had like answer to a similar question. I think if you answered it wrong, like if you gave, that's the probability that they're under the, or don't meet the requirement. If you gave the probability they did meet the requirement and it was correct, they'd give you partial for finding something and like you misread. It'd be an I otherwise. Part B, they split it up between the binomial or the sample distribution way of doing it. So either you state that it's a binomial distribution, or you give the parameters of the normal curve, which that normal distribution that comes from the sample of the proportion, you need to talk about P and N. So P and N need to appear. And in my formula, so long as I stated them, so there's P, there's N. They appear in this formula. So that would get me the point. So make sure it's somewhere you stated something about P and something about N if you did that other method. So getting the correct answer, that would be those percentages at the bottom. And you need the supporting work of some sort. So when I was showing this, because this one was really calculation-based, I would have to show at least some of this, like a calculator gave me this, and I subtracted it from 1, that kind of business. Or over here, basically, look, I got these formulas and got a z-score and put it in the calculator. So I may have showed a little more work than you need to, but you can't just put the plain answer down. If you put the answer down, there was no supporting work, you won't get it, all right? So basically, you have to have the parameters of whatever distribution you're using, the correct answer, and some calculation that goes with it. If you got all those things, again, E, 2 out of 3 is a P. Otherwise, you get nothing. So what really stinks about this is you have the correct answer, but you didn't show the work or state these things in the work, you get nothing. They must think you looked at somebody else or something, even though this year you'd be taking it by yourself, but whatever. All right, so part C is the stratification question. You have to say that with the stratification that it's more likely, right, that because they basically asked about the people who weren't going to, that were not going to qualify, were they more, less, or equally likely to be represented. So you need to say, well, those people who aren't qualified are being overrepresented. They're more likely to be picked through the stratified sample than they would naturally be. You need to justify it by comparing to the original, that basically we're expecting that kind of person to come in 22.3% of the time. The stratification is not done correctly. It's forcing 30% of the time. So it's overrepresenting those people and sort of biasing whatever results it'll get toward making this group overrepresented. All right, so E is if you state both things. P is one. You have to say one. So this isn't, oh, you get one of these correct. You have to have one stated. If you have a weak version of 2, you'll get the P. If you don't have number 1, you don't get anything. All right, and then the same business here with the E, EEP. Once again, I think I forgot the EPI. I think I did that every time. I'm making these videos, I'm going to catch it every time. And then this is if you just get like 1 right or 2 partially and then 0. So you can see how you did and why I would have graded you like I did. All right. So that ends this video on AP Problem 3. Next time we'll do AP Problem 4. Until then.